Hello everyone, welcome to this second ML2 tutorial. Today, I'll be walking you through a multivariable regression task using the ExtraTreesRegressor model. We'll apply this machine learning technique to a real-world, concrete dataset and discuss how to evaluate the model's performance. Let's start with the concept of multivariable regression. This is the statistical method used to analyze the relationship between a continuous dependent variable and two or more independent variables. Unlike simple linear regression that considers just one input, multivariable regression allows us to model more complex systems by accounting for multiple predictors at once. It estimates the partial effect of each predictor while keeping others constant. This is especially useful in practical scenarios like predicting material properties, economic trends, or biomedical outcomes where many factors interact. Our study case focuses on predicting the compressive strength of concrete. This property measures how much axial load a concrete sample can bear before failing. It's a fundamental quality indicator on structural engineering. The test results can vary based on several factors, including the material mix and curing conditions. That's why it makes an excellent real-world example for multivariable regression. The dataset we're using has 1,030 rows and 9 columns. It includes 8 input features, like cement, water, aggregate content, and one target variable, which is the compressive strength. We will split the dataset so that 80% is used to train the model and the remaining 20% for testing. This ensures the model is evaluated on unseen data. The model we're using is the ExtraTreesRegressor, short for extremely randomized trees. This ensemble learning method builds multiple unpruned trees and averages their predictions. What sets it apart is the high level of randomness introduced during training. At each tree node, it randomly selects a subset of features at split points rather than searching for the best split. This randomness helps reduce overfitting and improves training efficiency while still delivering competitive performance. Once the model is trained, we use it to predict the compressive strength values for the test set. We evaluated the model using R-squared score, which tells us how well the model explains the variance in the target variable. A higher R-squared value means the model's prediction closely matches the actual results, indicating good performance. Let's begin by setting up our project. Under the project scope, enter the project name. Here we call it ExtraTreesRegression Demo. Then, in the description box, briefly describe what the project is. In the data type section, we choose tabular data from the drop-down list, and then we choose Upload CSV, and then we click this button to upload our data. After successfully uploading our data, the data can be seen on the table section and the data section. The table section shows the details of this dataset, for example, all of the columns, and if we want to investigate more rows, we can click Next. And in the data section, this is the summary of this dataset, for example, NOR instances, data types, and unique values. Now let's move to pre-processing. In the target label drop-down list, we choose the last column of this dataset, which is the concrete compressive strength. And then in the method section, we choose machine learning algorithm. In the algorithm section, let's choose our ExtraTreesRegression. The regression models are on the bottom of this list. Then, in the matrix section, we choose R-square to evaluate our model. And then we click Perform. Now we can see our evaluation results here. The R-squared score is 0.94. This plot is good for linear regression. It's not ideal for multivariable regression because we have multiple input. Here is the result of our prediction. If we scroll to the right side, we can see y-test and y-predict. Y-test means the actual value from our dataset, and y-predict means the predicted value from our model. We can tell the y-test values and the y-predict values are really close. And also, R-squared equal 0.94 means the predictions are very accurate. Thank you for watching.